Alright, today we're talking about taking the derivative of ln's, logs, e to the u, and a to the u functions. So, let's get started right off the bat with some examples of ln functions. So, we have y equals the ln of 3x minus 5 over x plus 1. Before we start and to tackle this problem, I'm going to go back and remind you of the properties of logs. We have a quotient rule, or quotient property, and when you have that, you have the to take the derivative, or to be able to take the derivative, you have to take the ln of a minus the ln of b. So the ln of what's on top minus the ln of what's on bottom. So let's separate this. The ln of 3x minus 5 minus the ln of x plus 1. Alright, so now to take the derivative, we have to use our derivative rules. The derivative rule, or the rule for taking the derivative of an ln function, you take the derivative of u, which in this case is 3x minus 5, over u, which is 3x minus 5 again. So the derivative of 3x minus 5 is simply 3, and then over u over 3x minus 5 minus, bringing that down, the x plus 1, the derivative of x plus 1 is simply 1 over that. Alright, you can either leave your answer like this, it's just that simple, or you can get a common denominator, which leaves you with a negative 2 over 3x minus 5 and x plus 1. That was bothering me. Alright, so ln's are as simple as that. Alright, the next problems that we're going to do are e to the u's. Our function is y equals 5e to the x to the 5th. So, our rule for taking the derivative of an e to the u function, we take the derivative of u, which is the exponent, so the derivative of u, times e to the u, so just simply times itself. So, with this 5 out front, we have to multiply 5 by the derivative of x to the 5th, which is 5x to the 4th, and then again we have to multiply that by e to the x to the 5th. So when we multiply 5 and 5x to the 4th together, we get 25x to the 4th times e to the x to the 5th. And that, again, simply your answer. Alright, the next one that we're going to do, we're going to talk about taking the derivative of log functions. So we have y equals log 5x plus 3. Remember, when there's not a base down here, there's an imaginary 10. So what we have to do with this, the rule for taking the derivative of log functions, you take the derivative of u, which is 5x plus 3. The derivative of 5x plus 3 is simply 5 all over the ln of a, the ln of your base, which in this case is the ln of 10, times your u itself, so times 5x plus 3. That is as simple and as simplified as that one gets. I'm going to jump over here and talk about taking the derivative of an a to the u function. So we have y equals 9 to the 2x squared plus 1. The rule for taking the derivative of an a to the u function, you take the ln of a, the ln of your base, so the ln of 9, times the a to the u, so times your function itself, 9 to the 2x squared plus 1, times u prime, so times the derivative of your exponent, which in this case is 4x. And that is as simple as that one gets. These derivatives are pretty easy. Again, just make sure that you remember your basic rules and properties for ln's and sometimes e to the u's get a little tricky with your e properties. Yeah, alright.
There's 10 again, just for the heck of it.